In this video, we'll summarize some of the thoughts and decisions we make when trying to solve a non-homogeneous second-order equation by undetermined coefficients. So the idea is we have a non-homogeneous equation of the form the y double prime plus by prime plus cy equals some function g of t. There could be an a in front here, it doesn't matter. We can solve the homogeneous part by our standard methods, and then we need to figure out what to guess for the non-homogeneous part. The basic idea is you want to guess something that in some sense looks like g of t, but has as yet undetermined coefficients that we're going to solve for to figure out the exact function that solves this second order equation. So if g of t is a polynomial, you guess a polynomial of that same degree, and you have to include every single term going all the way down to the constant term. All the way down here. So the point here is, even if you just see, say, a t cubed on the right side, you have to guess a t cubed, t squared, t, and a constant. The point there is, if I differentiate t cubed, I pick up t squared. Differentiate t squared, pick up t. Differentiate t, pick up constants. Differentiate constants, they just go away. So basically trying to include everything that could ever come out of differentiating this expression over and over and over again. Then include everything down from the highest degree that I see all the way down to the constant term. If it's an exponential, that's easy, you just guess that same exponential. If you see a sine or a cosine term, you guess both the sine and cosine of that same argument. So if we have either cosine of AT or sine of AT, we're going to guess the combination of those two terms. So an A cosine of AT plus a B sine of AT. And then we have the adjustments to make when things fail. So if something solves the homogeneous problem, you can't guess it for the non-homogeneous problem. You multiply by t until it stops solving the homogeneous problem. And then lastly, if you see a sum or difference of any of these terms, or a product, you're going to guess the sum, difference, or product respectively of the guesses you would make for those terms. You don't really have to include difference here because it's just a sum with a negative coefficient, but the idea still stands. So for example, if I had a function g of t that was t squared e to the 3t plus cosine of 2t, what would I guess for this, assuming nothing solves the homogeneous problem? Well, from the t squared, I should guess a polynomial of degree 2 going from t squared all the way down to t. So an a t squared plus a b t plus c. From e to the 3t, I should guess some constant times e to the 3t. And from the cosine, I should guess both the sine and the cosine with argument 2t. Now when I multiply these together, I can kind of get rid of this d because it's just going to be absorbed into all the different constants here. We end up with 5 constants to solve for because my guess should be an a t squared e to the 3t plus a b t e to the 3t plus c e to the 3t, and then plus e cosine of 2t plus f sine of 2t. And this should have been a sign up here, by the way. That would be my guess for a problem like this. Now, what happens if, say, e to the 3t solves the homogeneous problem? Well, then I have to multiply this term here by t, but then it matches with this term, so I should multiply it by t, and then multiply this one by t as well because they will all match. So I have to multiply all the e to the 3 corresponding terms by t to move them all up 1 degree if e to the 3t solves the homogeneous problem. So in that case, I would have a t cubed, a t squared, and a t here. I wouldn't need a just e to the 3t term because I know that solves the homogeneous problem. It's not going to help me. And then leave this one alone at the e and the f. Let's say you could think about choosing your appropriate guess for these problems. That's probably the trickiest part of these undetermined coefficient problems, is just picking with the appropriate guess that's going to work out correctly. After that's pretty mechanical to get to the actual answer and work out what the answer is for these sorts of problems. Thankfully, there's always a safety check in that if you make the wrong guess, you will not be able to solve the problem. So if you get to a point where you can't work out this and you get something equaling 0 or something that's not going to work out, there's a decent chance it came from the fact that you made the wrong guess at the start. So you can go back and check your guess again to see if you should change it at all before you re-go through the problem to get to the actual answer. Because if it's set up right, you'll be able to solve it out. If it's not going to work. There's your methodology for choosing guesses and how you go about setting these problems up to solve problems by undetermined coefficients.